Hi everyone. I'm very passionate about autonomous vehicles, or really anything to do with the self-driving car industry. So for this project, I decided to focus on how vehicles are able to detect the lanes in front of them. For the data collection process, I downloaded 12,000 recorded driving images, and each image came with a corresponding label, where the label was a labeled lane for that image. The labels were set up as text files which contained polynomial fittings for each lane marking. And then these polynomials were then converted to true images, and those were the images that my model was to be trained for. For the image processing, what I did was I took all the images and I converted them to a standardized size of 80 by 160 by 3. I normalized the RGB colors to be from the range of 0 to 255 to a new range of 0 to 1, which is ideal for training convolutional neural networks using TensorFlow Keras. And then the labeled data set was converted to solely use the G channel in an RGB image. Then for training, I started with a CNN baseline model, and this model had one inner layer, so it was essentially the simplest baseline that was still a convolutional neural net. This model was evaluated using mean squared error, and essentially I saw at around 10 epochs the model converged to a loss of around 0.07. Then when building my fully connected model, this is the model I iterated on multiple times, I built a very deep model which had 13 deep layers, and I used a encoder-decoder architecture for this model. This is very effective for doing anything with very dense images. So this is good for pixel segmentation. And the output layer of this model is a pixel array, which I then evaluated against the true labeled lane image using regression. The results of this fully deep CNN model showed a mean squared error loss value of 0.0059, which is significantly below the baseline model. The optimal parameters I selected are shown here. As you can see, the baseline model essentially looked at all flat surfaces and recognized everything that was flat as a lane. However, when doing my fully connected model, the model successfully recognized where the roadways were and pinpointed the specific lane areas. However, it tended to struggle with looking very far in front of it at figuring out that that's a lane. So essentially anything that was within the image horizon would then get difficult. And the model also struggled in darker, shadowy conditions, likely because there were minimal training examples in darker conditions, and the model tended to struggle when there were like vehicles or any sort of object directly in front of the image. Here's some examples of the model predicting the roadway on completely unseen driving data. So you can see it does a relatively good job when there's nothing in front of the car and it's a very light image. However, on the bottom screen you can see a darker image. The model tends to struggle with pinpointing exactly where the lane is. In the future implementation, I would like to implement an autoencoder for the model. This will ideally, hopefully, get better results, lower loss values. And then I would like to combine the lane detection with object vehicle detection using YOLO v5. And then I would like to display the confidence of the lane markings as well as the radius of curvature continuously with each image. And I do currently have a basic implementation of a Flask app, although I'd like to implement it further. And then here I can show the Flask app. So essentially you pick an image. For example, here's an image of a car driving, totally unseen by the model. And then submit, and you can see the predicted lane for that image. Thank you very much.